In this video, we'll take a look at the trigonometric functions. So trigonometric functions that we're going to look at are really the ratios. We call them trigonometric ratios. So definition, let xy be any point other than the origin on the terminal side of an angle in standard position, and let r be the distance between the origin and the given point. So notice we have an xy point. That means that if we drop a horizontal and vertical, we get a right triangle with the bottom of side length x, this side length y, and then r is the radius. But that's going to be a value that we can find using Pythagorean theorem. So the angle that this makes, we can take a look at three different sides and we can write ratios of each of the sides. So there are 6 different ratios we can look at. If we take a look at y, ratio with r, it's called the sine of an angle. The cosine of an angle is the ratio of x to r, and the tangent is the ratio of y to x. So usually when we think about this and try to remember it, we look at it in relationship to the angle. The side opposite the angle is y. The side adjacent to the angle is x, and r is the hypotenuse of our right triangle. So the sine is opposite over hypotenuse. The cosine is adjacent over hypotenuse, and the tangent is opposite over adjacent. So to remember these ratios, there's SOH, CAH, TOA. Sine is opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. So those are the 3 trig ratios that if you know those 3, you can get the other 3 by taking the reciprocal. So if you know that the sine of your angle is y over r, the cosecant is r over y. If the cosine is x over r, the secant is r over x. And if the tangent is y over x, the cotangent is x over y. So these are called the reciprocal functions sometimes because they are reciprocals of the 3 basic trig functions. So altogether we have 6 different ratios we can write with 3 sides of a triangle. So we can find the side r, or that hypotenuse of the triangle, using something that you've done before called the Pythagorean theorem. So the Pythagorean theorem, if you have a triangle with legs A and B and a hypotenuse C, then the ratio there in the, they have a relationship that c squared, the longest side, is equal to a squared plus b squared, the squares of the 2 shorter sides. So this is what we use. If you have one side, if you have 2 sides, you can always find the 3rd side. So now we're going to take a look at how do you find values of our trig functions. So example 1 or example 2, find the values of the trigonometric functions of the standard position angle theta with its terminal side passing through the point 3, 4. So I'm going to draw that angle. There's our xy axis. Standard position means the initial side is on the x-axis, and the terminal side is going to go through the point 3, 4. So this is our angle theta, and the coordinates of this point are 3, 4. So I'm going to draw a right triangle containing up to that point. So there are an infinite number of points on this line. All of them will result in the same trig functions. You just need to know one point on the line to be able to find all the, or on the terminal side, to find all of the trig ratios. So now I'm going to label the triangle. I know that the length on the x-axis of my triangle is the x-coordinate, which is 3. The vertical distance is the y-coordinate, which is 4. And now I want to find the longest side. So I'll label that r. So I'm going to use Pythagorean theorem. R squared is equal to 3 squared plus 4 squared. r squared is equal to 9 plus 16, which is 25. Then square root both sides. This happened to be a perfect square, so the length of that side, r, is equal to 5. So now that I know all three sides of the triangle, I can find all of the trig functions. So the first is the sine. The sine of my angle is going to be opposite over hypotenuse. So that's going to be 4 over 5. Cosine of my angle is going to be adjacent over hypotenuse. The adjacent side to the angle is 3 over hypotenuse of 5. And the tangent of the angle is going to be the opposite, 4 over the adjacent side, 3. Once you have these three functions, then you can do the reciprocals for the other functions. So the reciprocal of sine is the cosecant, which is 5/4. Reciprocal of cosine is the secant, which would be 5/3. And the reciprocal of the tangent is the cotangent, which is equal to 3/4. So those are the 6 trig ratios or trig functions from the standard position angle. So sometimes you might be asked the question in a little bit different way. Maybe you don't have the exact point that they go through. So next example, if you know that you have an angle in the first quadrant and it has sine of 3/7, find the cosine and cotangent in exact form and then to approximate to 3 decimal places. So I'm going to draw. I know that the sine is opposite over hypotenuse. So I've got the measurements in my triangle, 3 and 7 of the opposite side and the hypotenuse. So I'm just going to pick a spot here, draw an angle, draw a triangle. I know that the side opposite is going to have measure 3, and I know the hypotenuse is going to have measure 7. So knowing the sine of the angle gives me 2 lengths in my triangle. So I can use, I'm going to use x this time, find the horizontal distance. So I'm going to use Pythagorean theorem again. This time we've got 7 squared is equal to 3 squared plus x squared. X is what we're looking for. 7 squared is 49 is equal to 3 squared, which is 9 plus x squared. Subtract 9 from each side. I get 40 is equal to x squared. Square root both sides. X is equal to the square root of 40. And now I need to simplify my square root. 40 is not a perfect square, and I know I have to because we want to express in exact form. The square root of 40 itself has a factor that's a perfect square. That's 4 times 10. So I can take the square root of 4 times the square root of 10. So the value of x is simplified is 2 times the square root of 10. So this length exact is 2 times the square root of 10. So if I want to find cosine, that's adjacent over hypotenuse. The adjacent side I just found was 2 times the square root of 10 divided by the hypotenuse, which is 7. That's in exact form. The cotangent is the reciprocal function of the tangent. Tangent is opposite over adjacent, so cotangent is adjacent over opposite. And that would be 2 square root of 10 divided by 3. So those would be in exact form. If you want them in decimal form, then you bring out the calculator. And for the first, I would take 2 times the square root of 10. I'm going to make sure that I hit the arrow key so I'm not square rooting the 7 divided by 7. Hit enter. So that's approximately 0.904. And then we would do the same thing with cotangent. We would take 2 times the square root of 10. and I'm going to hit the arrow key so that I'm not having the square root written anymore, divided by 3. And that's about 2.108. All right, so those are the 3 trig functions, or the 6 trigonometric functions. Once you know sine, cosine, and tangent, the reciprocals of those are the cosecant, secant, and cotangent.